So we are going to do the first few commands. First command is echo hello world. So what is the output of echo hello world? So this is going to be the output. Hello world. It will print hello world back to the terminal. Right? So if you type anything else with echo command, can you see the same outcome? Have you tried out to do that? Like let's say if I type my name, I should be able to print my name to the screen. So using echo command, you can print anything to the screen. So remember this command because we are going to use echo in shell scripting, right? If you want to print any statement to the terminal, so then you can use this echo command. Then we have date. So when you use date command, you can print the system date, right? As you can see, the system date is correct, but time is incorrect. So it will print system date and time. Okay. Those are very simple commands. Then we have host name. Now, when you type host name, those who are at home, you can see your machine's name, right? It's kind of your login name, machine number or something like that. Maybe you can see something like localhost, right? But in your machines, those who are joining from lab, they can see something like G0107, and somebody can see lab01 and machine number, something like that. So those who are in lab 2, they can see lab02 and their machine number. So this will display the machine name, right? Host name. Okay. So if you are joining from your own machine, now usually we are printing the local host, right? So at your home, if you try out with your own computer, you can see local host as the host name. But in this environment, we have changed it. Because as you can see, we have a lot of machines in here. So in order to manage it, we are giving separate names for each and every machine. So that's why we can see something like G0107, some number. So actually that is a machine number. Now, if you check your terminals, monitor, those who are in lab, you can check your monitor. There's a number printed on the monitor, right? There's a small sticker printed with the machine number. So that's same number is displayed in this terminal, right? So I'm working in G0107 machine. This side belongs to lab 3. So that's why we have some difference in numbering method. Okay. Then ARC, ARCH. With the name, you can see it's something like architecture. Architecture. What's the architecture? That's the system architecture, right? It will display the system architecture. So this is going to print as x86-64. So that means CPU architecture, system architecture is 64-bit CPU, right? So I think your own laptop, your computers, most of them are 64-bit CPUs, right? If you have a very old machine, then you can find 32-bit CPU. But most of us are using 64-bit CPU. So that is the system architecture. Next, you have uname. Now you have an option. minus A is the option, right? You know that we are providing the Unix command and then option, and then you can pass targets. Now in these commands, most of these commands doesn't have any target. But in echo command, you found a target, command and the target. There was no options. But in uname minus A, we have Unix command option, no targets, right? Now try to provide uname only and see what will be the outcome. And then try to provide uname minus A. So I'm going to clear this since I want to take it into top. This is the outcome of uname only, command only, and then with option minus A, right? So it's a very long description, right? So how do we identify each and every point? Now there's a question. So what is option? You can check the manual page. If you don't know anything about these commands, you can check the manual page. So minus A. Anyway, minus A is displaying all the details related to that command.
Sounds balance sounds make a pen and the
Sounds still. Okay, anyway, right. So we have many technical issues today. Right. Now, if you don't know anything about commands, you can check the manual page. That's the solution. So you can go to the manual page using man command and provide uname, right? So I have opened another new window, right? Well, if you want, you can open a new window to check the manual page, right? So then you can check other commands. Now, when you read this manual page with minus A option, you can find it regarding all, right? You can display all information related to system, your operating system. So what are the other options? We have minus S, minus N, minus R. So there are few options. So if you check these options one by one, you can see the same order will display in here, right? Now, if you find what is uname S, minus S, there you can find it's Linux, right? So what is this minus S? That's the kernel name. So as the first information in this minus A, it will display the kernel name, right? That's what we can identify, right? This is the kernel name. Okay. Now you don't need to remember these things. Don't worry that you don't need to remember these things, because you can, now if you're working with a system, you can always check the manual page. Now, even I'm not going to remember this. I can't remember the order. I know what are this information it will display, but I can't remember the order. So how do I find it? The same order is there in the options list. If you give minus A, you can find it's Linux. Linux means that's the kernel name. So that would be the first information that it displays for uname minus A. So then if you try minus N, then it's G0107. So that was the host name, right? That was the host name, right? This is the host name or node name. Node or host name. Same information is there for uname minus a as the second part, second detail. So you can try to provide other options, minus r for kernel release. So this 5.4.047 generic, that is the information for kernel release. Right, kernel release. So likewise, you can find out what are the details provided with these options. So if you execute all of these things, you can see kernel version, right? So I'm not going to execute every command, but you can try to do it. So kernel version minus V option. Kernel version is #51 Ubuntu. Right. So this information up to 2020 with the date, right? So that was the date that we have installed these things into these machines. So most of you get the same date or closer date. And then we have information regarding CPU and system architecture. And also it will give you some details about the operating system and the hardware platform we are using. So why do we need to do these things? Now, when we are using shell scripting, that's the next lab session, lab 3. There we are going to use these Unix commands with program codes. So within these program codes, we are writing these Unix commands. Actually, we are using Unix commands within the shell scripting. We have few syntaxes like if, else statements, for loops, likewise. But otherwise, we have all the Unix commands included in the shell scripting program. So if I ask you to find out what is the kernel release, so then you have to use the correct command with the correct option. So during the online exam, if I ask you to use this to print kernel release of this machine, you have to use the correct command with the correct option, right? So then only you have to know what is the exact command, because you might forget what is the purpose of using uname. Uname is using to display the system details. So then we have DMESG. We usually say it as dmessage and pipeline operator and more. Now you have worked with more, right? Last week I showed you what is the purpose of using more. So if you have more content to display, you can weave one by one with more option, right? So we are going to combine two commands together. In between dmessage and more, you can find a pipeline operator. It's a operator, right? So last week you have learned 3 operators. What are they? 2 redirection operators, input redirection, output redirection, append operator. And today you are learning a new operator, that is pipeline operator. Okay. Okay, we'll try to execute it. Can you find out where the pipeline operator is? It's above the enter key. In between backspace and enter key, you can find your pipeline operator. And then more. Now, when you print this information, you can see it will print a lot of details. And at the end of this terminal, you can see more. But it's not going to say how much of percentage you have weaved in here, like in a text document. But last week I had to reduce the size of the screen. Can you remember that? I had to reduce the size or the resolution of the screen to show you that it's going to be with more and then some percentage. But this time we don't need, because if you press enter key, you can see a lot of information. So what is this? What is this information? It will print some data which is in the kernel ring buffer. How do you get this data? That is the bootstrap program. Now, when you switch on your computer, it will give a command to the master boot record, which is in the hard disk, right? In the physical structure. Now, in the second lab session, I told you that we have physical file system as well as logical or virtual file system. So we check what are the parts in the virtual file system. That was like root directory. Within the root directory, we have home, etc, bin, dev directory likewise. But when you check physical file system, we have something called super block, right? We have few parts in the physical file system: super block, inode blocks, and then data blocks, right? We are not going to the depth, right? But within the super block, there's a section called master boot record. So within that master boot record, there's a coding regarding this bootstrap program, right? So when you switch on the computer, it will start executing this bootstrap program, and it's going to start BIOS and check whether the system is working, all the devices are connecting, whether input output devices are working. So that information will send to the kernel ring buffer. So you are going to print all the records from the bootstrap program, right? So when I was starting this system, it's going to keep some records from the bootstrap program inside the kernel ring buffer. So when I execute dmessage command, I can see all of that, right? So if you want to see that information, you need to use actually dmessage command. You don't need more, right? So I can do the same thing. Now this is a different terminal. If I execute dmessage, see, I can see all of these information on the terminal, right? Same information will be there. But why do we use more? Because if you read this content, you can see we have to scroll up a lot. Because once you execute it and press enter, it will come to the end of the terminal and it will print the next shell prompt, right? So you have to scroll up to read out all the information. But if you provide more with pipeline option, then you can read one by one. Then you have the control. You can start from the beginning and read all the information step by step. That's the reason to use more. So remember, two different commands. Dmessage is one command, more is a different command. Okay. How do we combine them? With pipeline operator. So what is the purpose of pipeline then? We are taking the outcome of first command and send it to the second command as input. That's why we call it as a pipeline. Pipe. You're sending, imagine that you're sending some water through a pipe. So you are sending first input, right? Whatever the first thing that you are inputting into the pipe will go first, right? First in, first out. So in here also we are taking the outcome of the dmessage and direct it to the more command as an input. That's the purpose of pipeline. So rather than it's combining two commands, that's what we are going to do. Take the outcome of first one and send it to the next one as an input. Then from overall, we can take the outcome. So there's another pipeline operator command in question number 23, right? In 23 also you have the same thing. Okay. So when you read this information, you can see information related to BIOS, And the memory, random access memory, everything can be read. So how do we exit? Now I didn't read all the information. Now if you want to exit from this information, you can use Control C. Control key and C together. Control C. Then you can exit. Control C. So what is this Control C? It's actually generating a signal. So time to time, we may need to use Control C, Control Z, right? Likewise, we have to use some shortcut keys, Control Q. It's generating a signal. So that signal means it's giving an interrupt to the current action. Giving a small interrupt and it will terminate the current action. We have different options. It's not only for termination. We are going to see what are they with signal lab session, right? So remember, Control C is a signal. It will generate a signal. And then we have uptime. What we can be for uptime? Now it's going to display the time. Right? First information is going to display the time. It's 15:10 because this time is not correct. But if you check my time, which is on this date bar, we can see it's same, right? Up means up to this time. What is this? That's the time which we have run this system. So this is currently running for 1 hour and 4 minutes. This is up and running for 1 hour and 4 minutes. So you have different information. Right? So currently the system is up and running 1 hour and 4 minutes. How many users? I have only one user. I have logged into this system as student. My account is also student. So your accounts are also students. So you should see something like one user. But remember, Linux is supporting for multi-user. Right? It's a multi-user, multitasking operating system. So at the same time, we can log into separate accounts. And then we can display load averages for CPU. Load averages for CPU. So 1.94 is the load average for first minute. Then 1.81, that is the first 5 minutes. Load average of the CPU for first 5 minutes. And then we have first 15 minutes. That is the load average of the CPU. So this is going to show you how much time it is currently up and running. Then we have something interesting. If you don't know who you are, you can check your account details with who am I? Who am I? So who am I? It's just one word in here. Let me check whether it is going to support it separately. No. This option is not installed, but in some system I have seen this is also installed. Then we can see a lot of details regarding the current account. So my login is student. Right now it's going to display that information. So if you don't know about the login, actually you don't need this. When you open the terminal, it will display the login detail, right? Because in here, it's going to print the shell prompt with student at G0107. So student is the user login at G010, G0107 host, right? Student login in this host. So in your machines at home, sometimes you can see your login name, maybe your name at localhost. Sometimes, right? That depends according to the host name you have provided. Maybe your machine name can be displayed. And then we have a shell prompt, a different shell prompt. Now, when you compare with the previous recordings, I did my lab sessions with Kali Linux. There we found hash sign as the shell prompt, but in here we can see it's $sign. Before the $sign, what we can see? That's the tilde. Tilde sign in blue color. That's the current location I'm working. Right? So if you don't know about your account, you don't need to go to this who am I command. Simply you can read the shell prompt. Okay. So then again we have who command. That's also similar to the command that we have recently executed. So you can see the host details of this student account. So currently I'm using the default user, which is in the local host. So this student account, this is the date that we have started this machine, right? Current date, the time that we have switched on this computer, right? So right now we have spent around more than 1 hour. So at around 2 o'clock to 7, according to this machine, will display the time that we have switched on the computer with the current user. But if you have many logins, it's going to display all the details about the other users as well. Within brackets, there's a special information :0. That is the IP address of this current system. That's the IP address of the current system. Okay. So if you are going to log into a remote PC, let's say that you are going to try out VPN from here to your home PC. That's not possible, right? You can't log into a VPN from here to your PC, which is at home. But let's imagine that you try to do that. So then your user login will display the IP address of your home PC. Instead of this :0, then you can see the IP address of your home PC. But since you're working in the local host, since you're working in this machine, it's going to display as 0. Sometimes you can see IP address as 127.0.0.1. Right? So when you learn, I think when you are learning web development, I think this semester you are learning web development. There you can find the IP address of localhost. It's 127.0.0.1. Sometimes instead of this :C, you can see that IP address information. Okay. So any questions to ask? Even the online students, you can ask questions. Right. No questions. Then we have ID command. With ID command, we can see what are the user IDs, group IDs in this machine, and how many groups we have. That information can be displayed. User IDs, group IDs. So when we try to display ls minus l, right? You don't need to execute it, just for your reference, right? We saw something like this. There we have student in this third column. That was the user. Second column, again student. But in some cases, you can see root. So user and the group. So in here, with ID, you can see the same information. My user ID is student, and this is my group. So I belongs to my student account belongs to student group. But when you log into this Ubuntu from here, we have different accounts. For ITSD people, they have different user account. And when we are conducting exams, we are going to create some accounts under exam group. Because when we want to do IP exams or any operating system related examinations, we are going to use that account, that group. So within the exam group, we are going to create a separate user account for operating system online 1, operating system online 2, like this. So student is just one user within student group. Okay, we have only one account in that group. That's why. Okay. Last. So last, logged in users details. So currently my system is running using student account, right? So there we have root account details. So somewhere around in September 11, we have opened one this machine for root login. And sometimes we have start the PC with student account. So at this time you can see the status is it's crashed, right? So all the last logged in details can be viewed via this account, via this command, last command. Right. So then we'll try to do finger command. Execute it and tell me what is the outcome. Finger command. Okay, one more thing. Now, if you want to clear the screen, how do we clear it? I never type clear in here, right? You can type clear. That's okay. Here is the exact command to clear the screen, clear the previous records, but you can use Control L. Control L. Right? Let's say if I execute last, and if I want to clear the screen, you can type Control L. Now, finger command is not supported in here, right? Since the finger command is not installed. So it will provide you some details how to install these commands. If you don't have these commands in your PCs at home, also you can try out how to install it. That is apt install finger. That's the way that we can install any command into the system, but I'm not going to install it in here. Finger command will display all the user account details, right? So currently I have logged in as student. Via who am I command also, I was able to see what is my current login details. So it was displaying the user account was student. So other than this student account, if you execute PWD, it will show you where you're working, current directory. So now if I execute PWD, this is what I can see from this machine. It's root home student. So this type of information I can weave you as a combination in finger. Even it's going to display whether I'm using mail client in this machine. So here we have Thunderbird mail, right? You can see Thunderbird mail is the mail client which is installed in these Ubuntu machines. All of these accounts. Now, if I have created a email account using this Thunderbird email client, that also can be viewed via the finger details, finger information command. So all the email details, user account, what is the current login current directory that I am working, like let's say if I just open a terminal, what is the initial location that I can create any file or directory, that we can see. And also we can see shell, what is my current shell. So that information can be weaved even with 15, right? Number 15, command number 15, echo $shell, right? So if I execute echo $shell, it will display root bin bash. So that is my shell, right? So I'll tell you what is shell in lab 3, right? When I'm going to do the next lab session, I'll tell you what is this shell. But remember that information also can be viewed as one detail from finger. So finger is going to give all the details related to the current logged in user. Except the password, right? It's not going to display the password, but all the other details related to this account can be viewed. General information like shell, current directory, email accounts, whether currently we are using some terminals or the open terminal, status of the open terminal we can do. Then we have W. So when you check W command, can you see something you have already viewed before? Carefully read it now. I'm not waiting till you read all the details to execute these things. But if you read out these outcomes, you should be able to find some similarities. Some of these commands are replacing, right? So what is the information we have, which is common with the previous outcome? First line, right? So first line is about uptime. So with W command, you can see it's not only the information that we display, which is after this user TTY, something like that, but it's going to be a combination of uptime and something else. So user detail is there, user is student. TTY means that is the current terminal. Current terminal, I'm using localhost, and TTY is 0. Login time, log into this PC at around 7 o'clock in here. And also we can see CPU time, and currently what am I executing with user, lib, those. Other things are same as the load averages, everything is same as the uptime. Right. Now execute top and tell me what is the outcome. See whether you can find something similar from Windows environment also. Top command, that is command number 14, right? What is this top? What do you think about top? Can you find something similar in Windows environment? Have you seen something similar in Windows? Task manager. If you have ever open task manager, you should see something like this with process details. So this is the task manager in Ubuntu. Okay? You can see all the process IDs, account details, and the time and CPU usage, memory usage, everything can be weaved in here. How many processes are currently running? So as you can see, it's going to display uptime. Total number of processes, it's around 234 total number of processes. So time to time it change how many processes are running. So sometimes you can see one process is currently running. Sometimes it's changed for two processes like this. So when one is running, you can see the rest of the processes are sleeping. Their status is sleeping. And we don't have any terminated or zombie processes currently in the system. CPU usage can be viewed in here, overall CPU usage. But individually, you can view what are the CPU usages and memory usages for each and every processes. Right. So right now, you can see Zoom is using CPU usage highly. So all the processes can be viewed. So this S column is going to show you what is the current state of the process. This column S, most of these characters are S, right? S means sleeping. But some of them are going to show you that R. R means running, right? So top command is currently running. It's R, running. I means it's intermediate state. So it's like, it's not actually, sometimes it's running, but sometimes it's sleeping, right? Intermediate state. So how to exit? It's already there, right? You can press Q and exit, right? In your lab sheet, I have given you how to exit from top. You can press Q and exit. So recently we executed echo $shell. So I'm not going to re-execute it. Echo $shell will print what is the current working shell. Current working shell. So that's going to be bin bash in my system, but we can change it. If you want, we can change the current shell. So I'll tell you how to do these things in next lab session. But usually we can find so many shells within this system. So out of them, we are using, most of the time we are using bin bash as the current shell. So shell is like a account, right? It's like a user login for current. Now I'm using this system from 8:30 onwards. So this PC is switched on from 8:30 onwards. So from this time onwards until I close this or shut down this PC, it's going to create a session, something like session for this student login. So that's going to be the shell. Right. So then we have it's actually a combined echo command. So we are going to print some patterns in these sentences, in these wordings. Now, when you check these curly braces, we have three sets of words, right? Curly braces with three sets. And in each set, we have two wordings, con, pre, send, per, sed. So it's going to create 2 to the power 3 words, right? We have two wordings within one curly brace. Likewise, we have 3 sets. So we can use this combination and create 2 to the power 3 words. So this is the answer once you execute it. How it's going to form this 8 terms, 8 words? It takes con from the first set. Takes con from the first set. Right? And then it will take send. to form the first word, it take con and send and then s from the third set. Okay. That's how we can prepare consets. Con from first word group, send from the second word group, s from the third one. And we can form consets. So consented. Take con from the first set, send from the second set, ed from the last one. So making of consent, it's taking con from here, send, and s. And create the first term. And if you take con first, takes con from the first set per s. So if you want, you can change the letters and see what happens. It's going to see, like, provide you something similar. There's no relationship with the words that I have used in here. You can use anything within these sets. Then we have man, automatic, do. Now, when I try out this command, man automatic do, it's going to say that no manual entry for this. So we know that man is used to leave the manual page of any Unix command. For not even Unix command, we can consider even functions. Let's say that when you are doing C programs, if you don't know what is printf, or if you don't know what is scanf, you can check with manual page. So there also we are going to use man command. So in here, especially with Unix commands, we are using man command, but we don't have any entry with automatic do. So that's the standard error it's going to generate if you don't have a command in this system right now, something like that, right? So automatic do, I have provided this term automatic do within double quotes. What is the reason? Now, if I remove these things, see, it's going to consider these two wordings as two different terms. Automatic separately, and it says that no manual entry for automatic, and do, no manual entry for do. So it's going to consider, if I'm not using double quotes, it's going to consider these two are two wordings, two different wordings. And when you are creating directories or folders, sometimes you keep spaces, because I have seen that students are creating their folder with IT number, like IT and then keep space and then number. So remember, when you are using any name, any folder or directory name with spaces, if you don't enclose this name within double quotes, it's going to create two different directories. One directory for IT and separate directory for number. You can try to do that and see, right? That's what happened. Even if I try to create two directories with this automatic do, we can see the same information. See, automatic comes as separate directory. Do is a separate directory. So if you want to keep spaces and create a directory, this is how we can use it. You have to enclose the term within double quotes. So within this command, do we generate a standard error? We have few lessons to learn. How to create a directory or any file with spaces. There you have to use double quotes, right? And also we don't have a manual entry for this command. So if you don't have manual entry, system will generate a standard error. So with cat command, I told you that standard input, standard output, and standard error. So these are the three sections in any computer system. We are providing standard inputs via keyboard and mouse, reading outputs via standard outcome, standard output, that is terminal. Standard errors is also display via terminal. So this is a standard error. No manual entry, that's a standard error. But for different commands, you can see different outcome. Right now, when you execute any, most of the time the system calls, it will generate different type of standard errors, right? But for manual entries and like for an example, commands with related to Unix commands, you can see something like this. Now we have lost. Lost is not a command. This is not a command. So this, when you try to execute it, again, it's going to generate a standard error. So this is the standard error that is generated. But it will provide you some options. Now, this was not provided with old versions of Linux. Now, this is the updated version. That's why we can see some options. It's asking whether you are looking for GOST command or you are looking for most. This is something like last. Recently, we executed last command. So it's looking for something similar. See whether user is providing something like this. Mistakenly, if the user is providing something like, let's say, if I want to type last, if I mistakenly type O, then we can see this type of error. So system is thinking user might have done some mistake. That's why we can't see that. So they are giving some options. Otherwise, there's no command called lost, right? There's no command with lost. So clear, of course, you know what happens with clear. I gave you what is a shortcut for clear as well, right? So here it asks you to provide cal 2000. So that is the calendar of year 2000, right? So we don't need to go for year 2000. You can give the calendar of year 2022. So you can't see it properly in my screen because I have increased the size of the font, right? But I think in your screen you can see it properly, right? So current date is highlighted since I'm using the current year. Current date is highlighted in here in this calendar. If I wanted to see only 1 month, right, only to view the current month, I can provide cal 2 2022. So it's going to display only the current month, the calendar of the current month. So likewise, we can give any date, right? Any month. Let's say it's 10, 20. Even a future date can be viewed. Future month can be viewed. 2023. October we can give, right? So there we have cal. Cal used to display the calendar. First number, that's the current month, whatever the month that you're expecting, like number 1 to 12, right? And any year. You can provide any year. So have you tried to weave the information which I have given in here? Cal 9/17/52. 1752 is the past. So this is the current month, Cal 9/17/52. Observe it carefully. Can you see some difference? Now, for an example, if you take February month, we have only 28 days, so 29 days. This is from 9th, that is September. So usually we have 30 days. But when you observe it carefully, you can see 3 to 13 is missing. So the reason is there was a revolution in the calendar during that time period. So they changed calendar into a Gregorian calendar format. So that's how they have missed these dates. So that history is there in the calendar manual page. If you want, you can read that history details. So if you open the manual page of calendar, here we have that information. So they have switched from Julian calendar to Gregorian calendar format. So they had to miss certain days from the calendar. That's why we don't have from 3rd to 13th in September 1752. So if you read out these manual pages, of course, you can find very interesting information, right? I hope you are going to read it as a homework, because we don't have enough time to read all the manual pages. So you have to read it and find out what are the options we have. If you have read it, of course, it would be some advantage when you're doing your online examinations, right? You don't need to find out what are the commands. You can memorize the things and use them during the exams, online exams. So then we have BC minus L. BC command will open a calculator. It's actually a calculator. So with minus L, you know that it's going to display a lot of long details, right? Details in a long format. BC is a calculator. You can try to do some calculations. Let's say 1 plus 2, press enter, answer is 3. 3 minus 1, sorry, yeah, 3 minus 12, answer is minus 9, right? Like this, you can do some calculations. See, even it's going to support for shorting numbers. If I want to do some calculations, like 4.5 plus 6.33, it's going to display the answer is 10.83. So in a usual calculator also, these things are supported, right? We can calculate floating numbers, decimal numbers. So what is the advantage in here? When you do shell scripting, you may need to do some calculations. especially with floating numbers. Then you can call this BC calculator and do the calculation and provide the outcome. So how to exit? Control D. So now it's not Control C, now it's Control D. So it's a different signal. It will terminate the calculator. Right. Now again we have pipeline operator with echo command and BC minus L. Now with echo command, you know that we can print anything to the terminal, right? It will echo back to the terminal. BC minus L to do calculate. So two different commands used with pipeline operator. So if I use echo command separately, this is what happens. So echo 5 plus 4 is going to display 5 plus 4 to the terminal, right? But if I execute BC minus L, you saw what will happen. It's going to open the calculator. But now I'm going to combine them with pipeline operator. I can see the answer, final answer, 5 plus 4. So if I just provide echo 5 plus 4, it's not going to do the calculation. Because echo command will see whatever the things after echo command as text, as string values. So it's going to print them. So it's not going to be this as a number. But when you provide this echo command, outcome of echo to BC minus L, it's going to take these characters to the calculator and do the calculation. So 5 plus 4, outcome of 5 plus 4, outcome of 5 plus echo 5 plus 4 is this. That's going to pass as an input to the BC minus calculator. That's what happened. So now I think you can remember we discussed D message more. I told you that outcome of D message is sending as an input to the more command. So that's why we have limitation in weaving the content. Here it's not working with more. I'm taking the outcome of echo 5 plus 4 and send it as an input to the BC minus L command. So likewise, you can do any calculations. Even if you want to calculate floating numbers, you can do it, right? So when you type yes, please, it's going to print please continuously. For infinite time period, it's going to print please. So this is not only valid for please, right? So I use the control C or control Z. Using control C or control Z, you can exit, right? Even if you provide like hello world, it's going to print hello world for infinite time until you give control C to terminate it. Now when you provide control C, see what happens, it's printed as hat sign and C. That means it's kind of interruption. That's how what we can see with when you provide control C and control Q, you can see hat sign and the character. So with yes command, actually we are executing infinite number of iterations. And finally we have time sleep 5. So terminal will sleep for 5 seconds. Your terminal will sleep for 5 seconds. And it will print all the information regarding the sleep duration. So actually it was slept for 5.015 seconds. So likewise, you can keep your terminal sleep for any number of seconds, right? And finally, we have history. So when you give history command, you can see all the commands that you have executed recently. Only the commands can be viewed, right? You can't see any outcome. You can see what other commands you have executed. Now, this is going to be very important when you are executing, especially compilers. Because the most common problem I have seen, most of the students are replacing the source code with the outcome or executable file. Because with the compiling command, we have to provide output file name or executable file name and the source file. So most of them are replacing the source file with the output file. And if your code is correct, you can execute it for that moment. And that's the end. You can't retrieve the code because it's going to replace it. So if you have done something like that, how do we find it? You can check the history. From the history, you can see what are the commands you have executed, and also it's going to show you all the executions with whatever the compilers. That's also can be viewed, right? So that's the purpose of using history command. So we have discussed all 26 commands. I think now you can prepare your documentation with more information. So you have time till tomorrow midnight to upload your document. And so those who didn't try to prepare that document, you can do it. I saw very few number of submissions even in the first lab. So now we try to do C program, exercise 3. We discussed about exercise 2 last week, so I'm not going to repeat it now. We'll do exercise 3. Right. Now, when you're making files, especially within lab, you have to create a directory with your IT number. Because as I provided you at the very beginning, all of us are using common account, student account, right? So you don't have any IT number account with Ubuntu. Everybody is using student account. So therefore, you have to create a directory with your IT number. Okay. I hope you can remember the command. That is mkdir. I don't have IT number, right? So I'm going to create it as OS Lab2, right? OS Lab2. You can use your IT number because I'm asking you to create it with IT number because there are other students who are using the same machine. So they can delete it. Right? If they want, they can delete it. That's it. So if you want, you can take the previous command using up and down arrow keys. I hope you have see these things in your own machines. So I'm going to go inside this directory with cd command. You can go into this directory. So my current location is within OS Lab2 directory. And it's within the student student users home directory. Okay, so we are going to use VI editor, right? To open this file, you can use VI. That's the command to open the VI editor. And the file name, right? So if you read out this question, it says, create a source file named message.c. Message.c. And you can type this code segment in the VI editor, right? So it's very important to read the question and find what is the file name, because I have seen in your online examinations, I am asking you to create your file name with your IT number, right? But you never create it with your ID number, you just make it as online1.c or exercise1.c like this. So then we can't find it, because once we collect all your answers, when we are trying to mark it, we can't find. So that's why we are asking you to create with a specific name, right? Even in here, you have to use that. And passing the extension is very important. If you don't pass the extension, it will create a text file, right? This is a C program. I think you have seen these things in IP labs, right? When you are creating C++ file also, you have to use .cpp extension. But we are using only C language in OS, right? So therefore, we are using extension with .c. Right. So how do we start typing? I have to press I or insert key and change the VI editor mode into insert mode. So now I can type my coding. The coding is there in the lab sheet. You can simply type it. Now when I'm typing this coding, to observe it carefully, now if you don't get a chance to observe it, you can check the recording. The thing is, I have typed the main part, the main sections in the coding first. First thing is hash include and the header file, right? Then I type this int main, okay? And then I add these both curly braces. I open the curly brace, at the same time I closed it. So these are the mistakes that you do, right? You start the open curly brace, then you simply type it, but you forget to add the closing curly brace. And then once you compile it, you have so many errors. So then you don't know how to solve it, right? During an examination, it would be a very big issue, even missing a curly brace, because missing a curly brace will generate a very simple error, but you can't find it proper, right? So at the same time, if you open any bracket or curly brace, at the same time put the closing one, right? So once I do that, what was the next thing I did? Now adding curly braces, then I type return 0 first. I didn't start typing printf and things like that. I typed return 0 first. That's the basic structure of C program or C++. I think I have told you these things in C++, right? You have to type the basic structure of the program, then you can do anything within that code, right? See, I'm adding the curly brace, brackets and semicolon. Then I can type the statement, right? Anything that I want to print. So I'm not going to miss any curly braces, brackets, semicolons, because those things are very simple things. We have to add them while we are typing. Then we can do whatever the things in the middle. So adding double quotes also at the same time. Then type hello. I think you have already executed this program even in the lab session. This can be the second time you are executing hello world program. So \n for new line. Remember, backslash is used with escape characters. Backslash, the meaning of backslash means escape character. Escape character means n. Character n has a literal meaning. What is the literal meaning? It's a letter from the alphabet, right? So if you don't use this backslash, it will print letter n to the screen. So I want to escape the literal meaning of that character. So I'm escaping the literal meaning of character n as a letter. So now it has a different meaning. That's the new line. That's the purpose of using backslash. Okay, so we have already typed the code. Saving, press escape, colon, shift and colon sign, W to save it, Q to exit. Right? Colon WQ, escape colon WQ, and press enter. So then you will come back to the terminal. So now we have to execute it, compile and execute it. In the next page of your lab sheet, I have given you how to compile it and how to execute it. But you can check my screen and compile it. I'm using GCC compiler or CC compiler. GCC or CC compiler. -O. -O to create an output file. GCC compiler, using a GCC compiler, I am going to create an output or executable file. So we can provide that command using -O option. So executable file name is message, right? And source file name is message.c. So when you use the same name for source code and output file, very carefully use it, right? Otherwise, use a different name for your output for executable file, right? Because otherwise, it's going to replace the source code with output file. If you have any errors, it's going to display all the errors once you compile it. If you don't have any errors, you can give /message and press enter. It's going to print hello world to the screen. So it's a very simple program. The most important things that you have to find out, what is the header file? We use header file called stdio.h header file. And you have to write everything within the main function. And we are using main function return type as integer. Therefore, before you exit the program, you have to provide return 0. And within that, what I was doing is I wanted to print only hello world statement. So I was using printf function. That was the thing that we did. And when you are compiling, you have to use GCC compiler and always create an executable or output file for your compiler and source code name, right? So when you are executing your program, when you run your program, you have to use // and executable file name. So if I check my current location, ls-l, I have my source code as well as my executable file. Executable file is in green color, source code is in white color since the background is black. So those things are very basic things. So I want you to try out question number 4, exercise 4. It's a very simple code, but I want to do it as a homework. It's because you have to find out what are the manual pages I have asked you to read, right? So it's a very simple and you have very few number of lines of coding. If you can, you can write the source code, but I'll teach you how to do it, but you have to provide answers for exercise 4, even if it is a wrong answer, right? Okay, so submission, deadline is tomorrow before 12 midnight, right? You have to submit exercise 2, answers for exercise 2. And also I gave you 2 other questions from cat command, right? And the table. Lab2 sheet, you have table for less utility and more utility. You have to include that answer. And all the outcomes of this exercise 1 and what are the meanings of each and every command as a brief information, right? Don't copy the content from manual page and paste it, okay? And exercise 4, that's the new exercise as the home, right? So we'll wind up the session. You have ETF lectures after this. So when you leave the lab, you have to shut down the PC or set it as reboot. Okay, so I'm not going to execute it, but I'll show you how to do it. You can type init 0 and press enter, or else you can type reboot and press enter, right? So then it will reboot the machine. But if you want to copy anything to your pen drives, you can do it now and reboot the machine, right?